Good morning, class. How is everyone?
Good.
Good. Ready to learn? So last week we started looking at how to find the area of rectangles, and we're just going to review that information starting off today. So here I have a rectangle. Can I have someone come up to the board and label the base and height of this rectangle? Angela. Thank you. Very good. This is the base of our rectangle, and that's the height. Also on this side. So how do we use this information to find the area of our rectangle? Does anyone remember from last week? Adam.
We take the base times the height.
Yes, very good. The base times the height gives us the area of our rectangle. I'm going to write a couple examples so that we can practice our multiplying. What would the area of this rectangle be if our height is 3 and our base is 5? Angela?
15.
Yes. How did you find that?
5 times 3.
Great job. What about this rectangle with a height of 2 and a base of 7? Jenna?
14.
Yes.
You did 7 times 2.
Good job. I think you guys remember how we multiply upon the area. And if you remember why, it's because if we break our rectangle up to a height of 3 and a base of 5, if we were to sit here and count every square, it kind of takes a while. So we would count those up and get 15 for our area. It's a lot more efficient to just multiply the height times the base, and you'll get the same answer. So, we're going to look at a triangle. Who thinks they can try and label the base and height of this shape, the triangle, using your knowledge from the rectangle? Adam, you want to try?
Sure.
Thank you. All right, so Adam correctly labeled the base of our triangle, but our height is actually from this point down to our base. And we'll look more later as to how you find the area using those pieces of information. So, what I forgot to ask again was, why do you think you need to know the area of a rectangle in a real life situation? Can you think of that? An example I thought of is maybe you wanted to plant a vegetable garden and you would need to know how much space you have to plant all of your crops. Does anyone else have a real life example they can think of? Adam?
If I was gonna build a dog kennel,
Yeah, you'd want enough room for your dog to run around in, right? Good example. What about why we would need to find the area of a triangle in real life? Does anyone have an example of that? Adam?
you were gonna make a triangle-shaped garden.
Sure. Someone might want to do that, so you need to know the area to know how many crops to put in there. I also thought of a wind sail maybe if you're out sailing and how much area of your sail is with the wind. So there's another example. Good job. So today we're going to look at finding the area of different shapes, since we know how to find the area of a rectangle. And in order to do that, we need to know some of these terms or review them. So the first one is a polygon. And a polygon is a plane figure with at least 3 straight sides and angles. And there's a picture for an example. A parallelogram is a 4-sided flat shape with straight sides where the opposite sides are parallel. A base is the bottom of a line, or the bottom line of a shape. So here I do right there as an example. The height is the vertical distance from the top of a figure to its base. So again, with that triangle example, this is the top of our figure down to its base. And then a perpendicular line, or perpendicular lines, are lines that intersect each other at exactly a 90-degree angle. So what I'm going to have you do, I'm going to erase these terms, and I'll have you come to the board and match the terms I give you with the definitions. And we'll see if you understand these definitions. Okay, so now that you have your terms, can you come up one at a time and match your terms with the definitions? Great job, everybody. Thank you. So it looks like we have all of our terms matched. Polygon, a plane figure with at least 3 straight sides and angles. Parallelogram, 4-sided flat shape. Base is the bottom line of the shape. The height, vertical distance. And perpendicular lines are lines that intersect each other at exactly 90 degrees. Great job. So now I think we're ready to start talking about finding areas of different polygons. And the first one we're going to look